want to show you how to model a concrete bridge using STAADPro. So you click on STAADPro, it will launch. Okay, let me say I'm modeling a bridge with 12-meter span. So I click here, new project, I select space, I go here and type 12-meter bridge, concrete bridge. So I put concrete, then I go ahead and I click next and then click finish. So here you can see I'm using grid, and from here let's say 1 2 3 meters to 10 meters, and up here I have 1 to 10 meters. So I want to increase it to 12 meters because I'm working on the section of the cross sectional width is 12. So I go here and click edit and make it 12. Then I said okay. I come here, I select my bridge, the column is 10 meters. Then here the cross-sectional width is 12 meters and the column again is 10 meters. So I move this up and I click on snap mode, that is snap node or slash beam. So I'll move again here from 2 meters. I select my beam. I have my column, the second column. I click on snap node. I click on it again. I go to 6 meters. There's a column at the middle. I click on this and also click on the button, activate the button. Then I go to 10 meters and then select the next column. Then I click on snap node. Here I have how many columns? For the 12-meter width, I have 1, 2, 3, 4, 5. So I don't need these two columns because I want the bridge to have a cantilever, a cantilever beam and deck. So what I will do is to select this very one, this column, select the second one. I move to edit and I delete. So I've been able to delete it. So what I need to do is to highlight these three columns or pairs and then highlight the deck, and because I want to duplicate it, so I click here, and how many steps is for 4-meter steps. That is 4 spans, 4 different spans. It's a continuous bridge. Then here I'm working for 12-meter, or let's say I'm working on a 17-meter bridge. So let's call it 17-meter bridge. I select Z, global direction is Z. Then here I click link steps and I click OK. So you can see I have 1 2 3 4 4-meter bridge. You can see four spans bridge. That is 4 span. This is span 1, span 2, span 3, span 4. Then each of it is 17-meter span in length. Each of these spans, 4 spans we have here, and the width here is 12-meter. So what do I need to do? I remove this grid and then I also uncheck this. So I'll remove the highlights. Then I need to do the meshing. I click here and select the nodes to do the meshing, or to select my mesh size. So I click here, then you can see polygonal meshing, quadrilateral meshing. I need that of the quadrilateral, so I click OK. Here I said apply. I apply everything. You can see I've had the bridge structure has been refined in a mesh form, or in form of meshes. So using finite element procedure. So next, what I need to do is I need to add, because these are the columns now, while this is the deck. So I need to define the properties and also place a support here, because these columns are resting on a support. So what I need to do is to click this and then I click here on support to define the kind of support I want. I create a support, fixed type of support. I click add. So here I have this type of support. So I highlight it and then come here, select this, and then I say assign to selected nodes. I assign, then I close it. Then I return back to my view, my three-dimension view. So here you can see I have been able to apply nodes. Then the next thing I need to do is I define the properties because the columns these columns need to have, or the pairs, they need to have a sectional property. They need to, we need to know the dimension and also the deck and also the beams or the girders that are carrying the deck. So I come here and define under property. I'm going to define a property for the columns. They are circular columns of 1.2 meters, 0.2 meters. Then I add. Then I need a rectangular for the beam girders, the concrete beam girders. You can see the columns are of concrete material. Then for the girders, this is by 600 millimeter. This is by 450. So we'll put 0. Okay, this first one is 0.6, which is 600 millimeter. 0.6. And the second one is 0.45, 450 millimeter. So this is in meters. So I go ahead and add. So you can see I've defined for the girders. Then for the deck, I select thickness. I first of all close this and then select thickness. What thickness do I need? We need for the deck is 250 millimeter. So we select 0.250 and then we add. So we have the three properties. So we close this and then we have to highlight. We select for the columns. For us to apply this to the various columns or the pairs, we use this select tool, come to beams parallel to Y because the columns are on Y, they are standing, they are vertical. So you can see we've been able to highlight. Then we say assign to selected beams. We click here and say okay, we've assigned it. So now we want to assign this to the girders. So we say select beam parallel to what? First of all, x-axis. You can see the girders that are on this axis, x-axis. Then we'll go back again and select beams parallel to z-axis. So go ahead and we apply to selected beams. So we assign it. So we have that. So the next thing is the deck. So for the plate thickness, we use this cursor to select. This one is for the thickness of the deck. So come here and we highlight the deck. So assign to selected plate, we assign it. Then now we are done with assignment of the sections. So we close this. We come back and see if we can view what we have in 3D form. Okay, so you can see what we have in 3D form. These are deck in 3D form. You can see the piers or columns. So you can see the beams, the girders, and then the deck resting on the girders. So we go continue with our modeling. Now we need to apply loads. We have to define the loads, the temperature load. We have to define the other loads. So we start with definition. We need vehicular definitions. So we define our vehicular loads. Say add new. So here with our spacing is 2 meters. We are using load model 1. So according to Eurocode, 300 kilonewton. Second load is 300 kilonewton for the concentrated load. The distance is 2 meters. Then we hit enter. The next load step we have is concentrated load we have is 200 at a spacing of 1 meter from the previous one. We hit enter. With the next load is 200 at a spacing of 2 meters. So we add. Now we come to load case details. We have to define load case, different load case detail. We select for the dead load. We say DL for dead load, and then we add. We select for live load. We say LL, then we add. We select for temperature load. We apply TEMP for the temperature. Then we add. Then we now do load generation so that we can generate loads for those vehicular loads. So we save and then we say add. Now we close. So now that we have for the dead load, we add dead load. Here we have for the, we leave it the way it is for the self weight and then click add. We close. For the live load, we add. We have for our live load, we go to, because the live load are apply on the plates. So here we have the floor load, the plate loads. So here we use negative -9, the average load for the UDL according to load model 1, 9 kilonewton. On the y-axis, we add, we close. We go to the temperature, we add load, temperature load. According to the Euro code, temperature load, we have 15 for the maximum. For the differential, we have 8. So for concrete, deck on a concrete beam. So we add, we close it. Then for the generation of the load, we try to generate the load. Here we have the middle of the deck, the width of the deck is 12. So the middle of it starts at 6, 6, 6. This one is also 6. So the increment is 2 meters step. Then we go ahead and add. So we close. Now we've been able to create the loads. We have to assign them. The self load, we have to assign the self weight to every, all this the structure as a whole. So we assign to view. Click on it, then we assign to view. We assign. Now for the live load is only on the deck. So we select for the live load. We use the plate selection to select the deck and apply the live load on it, which we say assign to selected plates. We assign. Yes. Then we have the temperature load. We assign it to the whole property, the whole structure. So we click assign to view. So that's all. We are done with our load assignments. So the next thing we need to do now is we have to add property, the material property. And we know that the structure is wholly concrete. So we select material and we select concrete and say assign to view. We assign to view. So we are done with that. We can close. Then we go to analysis print, static check, add. Then we define, we close because we've already done perform analysis print. We close. Then we go back again to post print. We define commands, element forces and stresses. We add print element stresses. We add. Then we close. Then we'll come back to where we have defined the commands. We assign to view, assign, yes. Then we'll come here, print element stresses, assign to view, assign, yes. So now that we are done with this, the next thing we do is to run the analysis. We click on run analysis, we save. So you can see from here we have 0 error, 1 warning, 0 notes. So since we don't have any error Had it been we had error, we would have carried out the analysis or repeat the analysis. But since we don't have errors, so we go to post processing mode and we click OK. So this is the structure we have for the, you can see the results for the nodal displacements. These are our results. So we have, for us to view our results, stress analysis result, we click on plates. Here you can see the load case is temperature. Then we say maximum absolute. We apply and we click OK. You can see the stress results on the bridge deck. Then these are the results of our analysis. So you can see the shear membrane and bending stress results are shown here. So other results can be viewed from here. Go to results, then view value. We'll go to results, and here we have the values that we want to check. Same results. We select end shear, or if we are looking for maximum values, we select maximum. For shear, maximum results. For axial ends, displacement, maximum results. Combine bending and axial. We click annotation or annotate. So with this, we can be able to view the values. So for the displacements, we click on this. We have our results for the bending. The results are not showing. Let me make them show. View values. So we'll come here for the bending. We click maximum and we annotate. You can see the results are here, but they appear very small because each of them are on each nodes. So we have on each nodes. So you can see these are the results we have for the shear. We can also annotate for the shear maximum. We annotate. Click OK. So we'll go to the shear results. Shear at Z. Remove that of the bending. You can see the shear force results on the beam, on the structure. These are the shear force results. So if we want to remove that of the shear, we remove. Then we can also click for, we can also see for the bending. We annotate. Then here we click on this. You can see our bending results. They are here. So the results are clustered because we are considering results at each node. So for the contour diagram, we select maximum absolute, we apply, and we can view it. So other results are displayed here. You can see the various results we have for the shear membrane and bending. The summary is here. Then you can see the principal and the von Mises results are here. The global moments are here. The combined stresses, their results are here. So these are things that the results of the analysis using STAADPro to analyze a concrete bridge. So for For the steel bridge or steel deck, all we need to do for the load case, not for the load case, I beg your pardon, for the property section, we will include, we define that of a steel, a tapered eye. So we can now fix in the value for the deck and then put it back. So that is the difference between that of the concrete and that of the steel.